n drops of a liquid, small n drops of a liquid, small n means n number of drops of a liquid, each with surface energy capital E, each with surface energy capital E, join to form a single drop, join to form a single drop. In this process, option A, some energy will be absorbed, some energy will be absorbed. Option B, energy absorbed is capital E, first bracket starts, n minus n to the power 2/3, n minus n to the power 2/3, bracket close. Option C, energy released will be E bracket small n minus n to the power 1/3. Option D, energy released will be E bracket 2 to the power 2/3 minus 1, 2 to the power 2/3 minus 1. Acha, again I will repeat the options. Some energy will be absorbed, that is option A. Option B, energy absorbed is E into n minus n to the power 2/3. Acha, option C, energy released will be E into n minus n to the power 2/3. Check the option C. That is same as that of option B, but in option B it is absorbed, in option C it is released. But the numerical figure is C, mathematical figure is same in both option B and C. E minus E bracket n minus n to the power 2/3. Okay, and last one is E into 2 to the power 2/3 minus 1, energy released, that is. First option, some energy will be absorbed. Option B, energy absorbed is E bracket n minus n to the power 2/3, bracket close. Option C, energy released will be E bracket n minus n to the power 2/3, bracket close. Option D, energy released will be E bracket 2 to the power 2/3 minus 1, bracket closed. When the drop joins together, actually the surface area will change. Okay, and you know that surface tension can be described as surface energy stored per unit area. So from that logic you have to solve the problem. If you forget that part, open your book and read that portion once and then try to solve the problem. Book or any your notes what you have already prepared, check that and try to solve the problem. See, when the drops will combine together, the initial volume and final volume remain same. So from that you have a relation between the new radius and the previous radius. Okay, and accordingly the surface area will change. So that change in surface area you have to calculate. When the drop joins together, the surface area will increase. So calculate that surface area, then surface area, increase in surface area multiplied by surface tension will give you surface energy. That is the increase in surface energy. So first calculate the relation between the radius of the bigger drop and smaller drops. See, for any small droplets, I consider that volume is 4/3 pi capital R small r cube. Now n number of such droplets are there. They will combine to form a bigger drop. Let us consider bigger drops volume will be this one. So capital R is the radius of the bigger drop. So from that relation I can find capital R will be equal to n to the power 1/3 small r. Okay, so this is the first relation between the radius of the bigger drop and radius of the each small drop. Okay, now surface energy of each small drop initially E, that is 4 pi r square into surface tension, because surface energy per unit area equal to surface tension. So surface energy equal to area of the drop into surface tension. It is initially. Now there is an increase in it. There is a release of energy. When the drop combines, there is a release of energy. Why? Because drop combine means surface area increases, so the surface energy will decrease. Surface energy decreases means remaining energy will be released from the surface. So delta E will be equal to the initial surface energy, that is n into 4 pi r square s, because there are n droplets initially, each droplet have this energy, so n droplet have this energy. Okay, minus new area will be 4 pi capital R square into S. New surface energy will be, after combining, it will be 4 pi capital R square into S. From this I can write n into 4 pi r square s minus 4 pi capital R square. Capital R square means n to the power 2/3 small r square s. Now take 4 pi r square s common. It will be n minus n to the power 2/3. Now 4 pi r square s means E, that is E into n minus n to the power 2/3. This is the energy released. This one is the initial surface energy of n number of droplets. This one is the surface energy when droplets combine together. Surface area into surface tension is the surface energy. Since there are n number of droplets initially, so I multiply by n, and here they've joined together to form a single drop having radius capital R. So this is the new surface energy. So initial is larger means energy is released. Okay. Question number 13. A cylindrical tube of a spray pump. The cylindrical tube of a spray pump has a cross section of 8 centimeter square. 8 centimeter square, comma, one end of which has 40 fine holes. One end of which has 40 fine holes, each of area 40 fine holes, each of area 10 to the power minus 8 meter square. 10 to the power minus 8 meter square. Full stop. If the liquid flow inside the tube, with a speed of 0.15 meter per minute, 0.15 meter per minute, comma, the speed with which the liquid is ejected, through the holes is option A 50 meter per second, option B 5 meter per second, option C 0.05 meter per second, option D 0.5 meter per second. 4 meter square. Okay. Then V1, it is given 0.15 meter per minute, means 0.15 divided by 60 meter per second. Then A2 is 40 into its area of each pinhole is given 10 to the power minus 8 into 10 to the power minus 8 centimeter meter square. Then you have to find out the value of V2. Calculate. Each pinhole has an area of 10 to the power minus 8 meter square. So 40 pinholes having an area of 40 into 10 to the power minus 8 meter square. Then from this calculate for V2. So V2 will become 0.01 by 4 into 5 divided by 10 to the power minus 4. So it will be 10 to the power minus 2 into 10 to the power 4 divided by 20. 5 meter per second. Okay. Question number 15. A steel wire of length 2L, a steel wire of length 2L and area of cross section capital A is stretched within elastic limit, is stretched within elastic limit by suspending a mass, small m from its midpoint okay. The two ends of the wire are connected with rigid pillars. Two ends of the wire are connected with rigid pillars. Strain in the wire will be, option A, x square by 2L square, option A, x square by 2L square, option B, x by L, option C, x square by L square, option D, x square by 2L, where x is the deviation from the horizontal level. Because the midpoint after hanging the mass will go down, so that deviation is x. This is the rod, this is the wire connected between two rigid rods. So when you put certain amount of mass from its midpoint, then its midpoint depressed down by an amount, say x. The total length is 2L, so I can consider that half of the length is L. Then I can consider this length is root over of x, L square plus x square, right? So what is the increased length? What is the new length of the entire wire? It will be 2 into L square plus x square to the power half. Means this one is root over of x square plus L square. This one is also root over of L square plus x square. So 2 times this will be the new length. And what is initial length? 2L. So subtract this 2L. So we will get the increase in length. Okay. So increase in length will be new length minus initial length. Clear? Now, take L square common from this term. So it will come out as L, and inside the bracket it will be x square by L square to the power half minus 2L. from this first term I take L square common, so it will be 1 plus x square by L square, and when this L square come out after to the power half, it will be L only. Okay, now in the problem it is mentioned that this elongation is within elastic limit, so x is small compared to L square, so we can do the binomial expansion of this term. Using binomial expansion, we can write this term will be 1 plus x square by 2L square minus 2L. So just multiply and subtract, it will become x square by L. So this is the elongation. So when you multiply this 2L inside, first term will be 2L, this 2L and this 2L will cancel, and this 2L and 2L square, so it will be x square by L. Okay, so this is the elongation of the wire. Now you have to calculate strain. Strain means change in length by original length, that is delta L by original length is 2L. So it will be x square by 2L square, that is the answer. So first we have to calculate the new length. New length minus original length will give you the elongation, and since we are within the elastic limit, so we can use this binomial approximation because x is very less than L. So after binomial expansion, we can write that increase in length of the wire will be x square by L. So this increase in length by original length 2L will be the strain. At a constant rate, heat is supplied at a constant rate to an ice cube at a constant rate to an ice cube. After 2 seconds, the melting starts. After 2 seconds, the melting starts, and after next 20 seconds, the ice completely melts to water. Next 20 seconds, the ice completely melts to water. Okay, find the initial temperature of the ice cube. Find the initial temperature of the ice cube. Specific heat capacity of ice is 0.5 calorie gram inverse degree Celsius inverse. Specific heat capacity 0.5 calorie gram inverse degree Celsius inverse, and latent heat of melting of ice is 80 calorie gram inverse. 80 calorie gram inverse. Heat flow per second is constant. So let us consider in 1 second the heat transferred will be Q. So in 2 seconds, how many heat energy can be transferred? 2Q. So in 2 seconds, the heat transferred will be 2Q. And this amount of heat energy is used to increase the temperature of ice from initial level to 0 degree Celsius. So I can write this energy will be mass of the ice block into specific heat capacity of ice into rise in temperature. So initial temperature is considered as T. Final temperature is considered as 0 because the temperature from negative rises to 0 and then the melting begins. So it will be 0 minus T. So from this I get one equation. So it will be 2Q equal to M, S is 0.5 into T with a minus sign. This is my first equation. Okay. In next 20 seconds, how much heat is transferred? 20 Q, because per second Q amount of heat is transferred. So in next 20 seconds, heat transferred will be 20 Q. And due to that, entire ice melts, means M into L. So we can write 20 Q equal to M, L is 80. These are two equations. Then divide these two. 2Q by 20Q equal to minus M 0.5 into T divided by M into 80. 0 cancels, 2 cancel, 2 cancel, Q cancel, M cancel, M cancel. So now from this calculate minus 8 by 0.5 will be equal to T. So what is T? Minus 16 degree Celsius. So you have to build two equations from which Q and M will be cancelled after dividing. So eliminating Q and M, you can find the answer. So initially the temperature of the ice block is minus 16. So in first 2 seconds, due to supplying heat, the temperature rises because in that case the ice block is taking sensible heat. So the temperature rises to 0. After 0, next 20 seconds is used completely to melt the ice into water, and until the complete melting occurs, temperature will not increase. So that you cannot think that temperature of the water will increase in this 20 seconds, because until entire mass is converted to the other form, change of state occurs, during the latent heat transfer, temperature remain constant. A piece of ice falls from a height h. A piece of ice falls from a height h, so that it melts completely. Full stop. Only 1/4 of the heat produced, only 1/4 of the heat produced is absorbed by the ice. Only 1/4 of heat produced is absorbed by the ice, and all energy of ice gets converted, and all energy of ice gets converted into heat during its fall. Find the value of H. अच्छा, latent heat of ice 3.4 into 10 to the power 5 joule per kg. 3.4 into 10 to the power 5 joule per kg, that is given. Okay, now options. Option A 544 kilometer, 544 kilometer. Option B 136 kilometer. Option C 68 kilometer. Option D 34 kilometer. See, when the ice is falling from a height h, it has the potential energy initially, that is mgh. When it will come to the ground, it is said that 1/4 energy is absorbed. So 1/4 of mgh is absorbed as a latent heat by the ice. So we can write that mgh by 4 will be equal to ml. mgh by 4 will be equal to ml. So from that m will cancel. So h will be equal to 4l by g. That is 4 into L means 3.4 into 10 to the power 5 divided by 10. From that calculate, it will be 136 kilometer. No need to convert into calorie to joule because everything is given in joule. Three rods of same dimensions have thermal conductivities 3K, 2K and K. 3K, 2K and K. They are arranged as shown. With their ends at 100 degrees Celsius, 50 degrees Celsius and 0 degrees Celsius. The temperature of their junction is 3K, 2K, K. So we know that Q by T, that is thermal current, that is equal to Ka, difference of temperature means delta T divided by distance x. Ka delta T means T2 minus T1 divided by x. Now this thermal current for I can write here I equal to I1 plus I2. Then write this thermal current. This will be I means so thermal current will be same, means its temperature coefficient is 3K, A into 100 minus T divided by length X. This is equal to T minus 50, that is coefficient is 2K, A into T minus 50 divided by X, that is equal to Ka into T minus 0 divided by X. Because thermal current that is passing through this one is conductivity into area of cross section into difference of temperature by length. Similarly, that for the second rod will be conductivity into area into difference of temperature by length, and for the third rod same. So from this equation, Ka by X, this can be cancelled and solve for T. That is heat energy that is flowing per second through the first rod is divided into two parts. That's why we consider that heat flow per unit time, that is thermal current, is conserved. So thermal current I equal to thermal current I1 plus thermal current I2. So from this K by X will cancel, so it will be 3 into 100 minus 3T, that is equal to 2T minus 100 plus K plus T. Okay, so from this it will be 400 equal to 2T plus T, that is 6T. So T will be equal to 200 by 3 degrees Celsius, or nearly 66.66 degrees Celsius. to 54 degrees Celsius and to 54 degrees Celsius in the next 5 minutes. Certain quantity of water cools from 70 degrees Celsius to 60 degrees Celsius in first 5 minutes, and then to 54 degrees Celsius in next 5 minutes. The temperature of the surrounding is option A 45 degrees Celsius, option B 20 degrees Celsius, option C 42 degrees Celsius, option D 10 degrees Celsius. Options: 45 degrees Celsius, 20 degrees Celsius, 42 degrees Celsius, 10 degrees Celsius. If I consider initial temperature is T1, final temperature T2, so T1 minus T2 by delta T, that will be equal to K times T1 plus T2 by 2, that is the intermediate temperature, minus T naught. Use this form of Newton's law of cooling. You have to write two equations, then divide to eliminate K. Initially T1 is 70, T2 is 60. Then using that find one equation. Then again considering T1 60 and T2 54. Consider write down the second equation. Then divide these two equations. Then K will be eliminated. A cylindrical metallic rod in thermal contact with two reservoirs of heat at its two ends, comma, conducts an amount of heat Q in time t, conducts an amount of heat capital Q in time t. The metallic rod is melted and is formed into a rod of half of the radius of the original rod. The metallic rod is melted and the material is formed into a rod of half the radius of the original rod. What is the amount of heat conducted by the new rod when placed in thermal contact with the two reservoirs? What is the amount of heat conducted by the new rod when placed in thermal contact? When placed in thermal contact with the two reservoirs. With the two reservoirs. In time, for time t, means same time. Option A, q by 4. Option B, q by 16. Option C, 2q. Option D, q by 2.
So can you repeat the question?
A cylindrical metallic rod in thermal contact with two reservoirs of heat at its two ends conducts an amount of heat Q in time T. The metallic rod is melted and the material is formed into a rod of half the radius of the original rod. What is the amount of heat conducted by the new rod? What is the amount of heat conducted by the new rod when placed in thermal contact with the two reservoirs for time t? We know that Q equal to Ka, difference of temperature T2 minus T1, divided by L, suppose length of the conductor, into T. This one, Ka T2 minus T1 into T by L. Now see, temperature is time of heat flow remains same, so T is same. So T is constant in both the cases. K is remains same because the material is not changed. After melting, it is again formed the same material. Okay, so this material remains same, so K remains same. Difference of temperature remains same because heat reservoirs are not changed. So this quantity and this quantity remain same in both the cases. So I can write that Q is actually proportional to A by L. Okay, then I can write Q1 by Q2 or Q by Q prime, say Q by Q prime equal to A by L divided by A prime by L prime. Q by Q prime, then next case I consider prime. First case I can consider Q by Q prime. This will be equal to A by L divided by A prime by L prime. Now Q by Q prime, that is equal to A by L into L prime by A prime. Okay, but after melting again another rod is prepared, but in both the cases volume of the rod remain same. So I can consider V equal to V prime. So in first case volume means pi r square H. You can also consider or directly write A into L because it is cylinder. So it is previously A into L previously. Now it is A prime L prime. Now what is A previously? Pi r square, and now A prime will be pi, radius is half, so it is r square by 4 into L prime. Okay, so what happens? Pi cancel, r square cancel, so L prime equal to 4L. L prime will become 4L. Okay, then substitute and calculate. This is q by q prime. Now A means pi r square by L into this one L prime, that is 4L, divided by A prime. A prime means pi r by 2 whole square. R by 2 whole square means r square by 4. So pi cancel, r square cancel, L cancel. So it is coming q by q prime, that is equal to 16. So q prime equal to q by 16. Okay, quadratic equation is discussed in the class. Quadratic equation, because quadratic equation is required very much for solving physics problem. There are kinematics problem, there are other types of problem in electrostatics and everywhere. Quadratic equation and their roots and all these formulas, the discriminant formula, all these things. How to solve quadratic equation, you know? Let me check. You know this symbol? That is called mod x. Mod x means strictly positive, because if I give mod of -2, it will be 2. Okay, fine. Very good. I will give you a very easy quadratic equation for solve. Solve for the value of x. Minus 6 minus 1. Simple middle term factor and solve. minus 2.
minus 3.
Just substitute this value in the ones in the equation given.
Yes, sir.
Put equation given is 6. Put x equal to minus 2. It will be 4. It will be 10 plus 6. 0 is not coming.
It's not coming.
See, you know that mod x, if x is greater than 0, mod x will be plus x, and if x is less than 0, mod x will be minus x. So if you consider mod x positive and solve it, then mod x equal to x for x greater than 0 you can solve, and you will get the value x equal to minus 2 comma minus 3. But none of the value when substituted on the left side will satisfy the equation, because minus 2's mod will be plus, minus 3's mod will be plus, and it is not satisfying. If you consider mod x equal to minus x, means x less than 0, then the values will come x equal to 2, x equal to 3. Again, if you substitute, it will not satisfy. So it looks like quadratic equation, but it will not satisfy. Why? By seeing the problem, immediately you can answer. No need for calculation. Sum of 3 positive numbers cannot be 0. Square term, strictly positive. This is a mod term, strictly positive. This is already a positive term. So how can 3 positive numbers sum be 0? So it looks like quadratic equation, but if x is real number, then it is not possible. It is only possible if x is imaginary number or complex number.